Alright, this talk is going to be very, very simple because, well, it's simple it's easy to understand. Astronomers, they don't like talking about chemistry for some reason. I don't know why. They obsess with spectrographs, and they obsess over Big Bang nonsense and all that crap. What they should be focusing on is chemistry. And you have two types of main heat absorbing or heat releasing reactions inside of chemistry. The first one, okay, this is just a little representation, and this is the amount of enthalpy, or I should say energy. I know Bill Gates' crowd is going to be very disappointed that I'm going this route, but you know, I don't think the world is made of ropes. But anyways, progress of reaction will go this way. Okay? Basically, that just means time. Alright, so you have the reactants up here, and as time goes by, the reactants energy is lowered, and then you have the products, okay? And as this transition occurs, since the amount of energy was high right here, and the amount of energy drops, guess what had to happen? It had to release the energy as heat, okay? Or HV, light. This is what's called an exothermic reaction. This basic graph right here is the reason why stars in their more evolved state, where they don't have spectrums anymore, still radiate. Jupiter radiates more energy than it receives from the sun. Neptune releases more energy than it receives from the sun. These objects radiate more energy than they receive from their host stars because of chemistry. Alright? Chemists should be allowed to talk about astronomical matters, but since they compartmentalize the sciences, that doesn't seem to happen. But this is why the older evolved stars are radiating exothermic chemical reactions, where reactants such as oxygen gas is combining with hydrogen gas, creating water. Now the opposite of that is an endothermic reaction. Now this is going to come as a shock to some people. This amount of energy again. Okay, and time. So basically, endothermic reactions are the opposite. You have your reactants, okay? Down here, they absorb energy, and then they become the products. So what would happen? Energy needs to be absorbed, okay? This means that the surroundings are going to be very, very cold. Okay? Because it's pulling the energy from the surroundings to make the products. Now, there's a concept I want to introduce to my listeners that I guarantee you're not going to find anywhere on the internet. But the bow tie nebula is supposedly cold, Okay, here's the nebula, here's this little central object, here are the two lobes. Okay, now this isn't a really good drawing, so the two lobes are going out like this. Okay. Now what I think is happening is that this is a star being born. Because this area is cold. Cold, cold, very, very cold. The coldest temperatures that we've ever recorded in interstellar space. Now, why on earth would something such as a dying star have cold lobes coming out of it? Now, if you understand thermodynamics, you can't have cold flow. Cold doesn't flow, okay? Cold doesn't flow to a hot object. It's always a hot object to a cold object. Meaning, if this area is cold, that means this area is getting hotter. In other words, the star is in formation. It's forming in the central regions of that nebula. That is what a burning star looks like. Hopefully people can understand the difference between exothermic and endothermic. Endothermic would be stars being born. Exothermic would be the stars dying and releasing all the heat. Hopefully that helps. If you have any comments or questions, please post them below.